On a remote mountain, in one of the most inhospitable places you can imagine, we're building a machine designed to look back to the dawn of creation. It's absolutely incredible. So today, we're going to dive into how this thing is actually taking shape.
I mean, how do you see the beginning of time? It sounds like a question straight out of science fiction, right? But it's the real deal. It's the whole reason behind one of the most ambitious projects we've ever attempted. And to even begin to answer it, well, you have to build something truly extraordinary. Okay, get ready for some numbers that are just mind-blowing. The images from this new telescope, they're going to be 15 times sharper than what we get from the legendary Hubble. I mean, just stop and think about that for a second. Imagine what we're going to see with that kind of clarity. And just how far can it see? Try 13.5 billion light years away. So what does that actually mean? It means we're capturing light that started its journey to us when the universe was just a baby. We're not just looking at stars, we're looking back in time. We are literally building a time machine. So what is this thing? Well, it has a pretty straightforward name, the Extremely Large Telescope, or ELT for short. And it is a truly monumental project, being built in a place you would absolutely never expect to find a multi-billion-dollar piece of high-tech gear. Which, of course, brings us to the first big question. Why? Why on earth would you build our most advanced window to the universe in the middle of the Atacama Desert in Chile? I mean, this is the driest non-polar desert in the world. It seems crazy, right?
Well, it turns out the very same things that make this place so hostile to us make it absolutely perfect for looking at the stars. It's a fantastic paradox. You get an unbelievable 320 clear nights a year. It's so remote, there's basically zero light pollution. And you're so high up, you're above most of the clouds and that thick, sooky part of the atmosphere that messes up the view.
And get this, there are parts of this desert that have never recorded a single drop of rain in history. Not one. Why does that matter? Well, water vapor in the air is like looking through a blurry window. It messes with the starlight. So a place where it basically never rains, that's an astronomer's paradise. That dryness is the secret sauce for getting the absolute sharpest view of the universe.
Okay, so you found the perfect spot. Easy, right? Not so fast. Choosing the location is one thing. Actually building there is a whole different ballgame. We're talking about an epic quest here. Nothing short of taming a 10,000-foot mountain peak.
And the timeline for this, wow, it just gives you a sense of the scale. They picked the site way back in 2010. Then, in 2014, they made the wild decision to literally blow the top off the mountain. And we're still looking ahead to 2029 for what they call first light. That's the magic moment the telescope opens its eye for the very first time. This is a multi-decade journey.
So why blow the top off? Well, to create a flat base big enough for this massive telescope dome, the engineers had to move, wait for it, 4.7 million cubic meters of rock and dirt. That's a number so huge it's kind of hard to even wrap your head around.
So let's try to put that into perspective. Picture almost 2,000 Olympic-sized swimming pools. Now fill every single one of them to the top with mountain rock. That's how much stuff they had to move just to clear the ground and get started. But, blowing up a mountaintop doesn't exactly go off without a hitch. Leveling the peak was just the start of their headaches. Turns out the blast fractured the mountain's core, making the ground totally unstable. They had sinkholes popping up. Oh, and did I mention the entire region is a major earthquake zone? Yeah, it was an engineering nightmare. So what do? How do you protect this priceless, incredibly sensitive instrument from shaking itself to pieces? The solution is just brilliant. It's called seismic isolation. The entire 6,000-ton dome basically floats on these huge hydraulic shock absorbers. So the ground can shake all at once, but the telescope itself stays perfectly still. Okay, so they managed to tame the mountain. Now let's go inside the dome and check out the revolutionary tech that's going to let us see farther and clearer than ever before in human history. And this is where you really see the leap in power. Just look at the main mirror. Hubble's is about 2.4 meters across. The ELT's? It's 39 meters. It's not one solid piece, but almost 800 hexagonal mirrors all working together. And the light gathering power? It's 100 million times more powerful than your own eye. This isn't just an upgrade, it's a total game changer. Now here's where things get really futuristic. You know how stars twinkle? That's our atmosphere blurring the view. The ELT has an amazing trick to fix that, called adaptive optics.
First, it shoots these powerful lasers 90 kilometers up into the sky to create a fake artificial star. Then, a supercomputer watches how that fake star twinkles, and in real time, it tells a super flexible mirror to bend and warp hundreds of times a second to cancel out the distortion. The result? A perfectly crisp, untwinkled image. It's incredible.
So, all of this mind-bending engineering, the crazy technology, the mountaintop, it's all for one reason. It's to help us answer some of the biggest, most profound questions we've ever dared to ask.
And man, what a cosmic to-do list it has. The ELT will be powerful enough to take the first ever direct photos of Earth-like planets around other stars. But it gets better. It can actually analyze the light from that planet's atmosphere and look for the chemical signs of life. We're talking water, oxygen, maybe even signs of pollution from an alien civilization. It's also going to push our vision of the past even further. We're talking about seeing 100 million years closer to the Big Bang than even Hubble can. We're going to get tantalizingly close to seeing the universe's baby pictures, the moment the very first galaxies flickered into existence.
And this really gets to the heart of it all. For the first time, we can look at a planet light years away and seriously ask, does it have water? Does it have oxygen? For all of human history, this has been science fiction, pure speculation. The ELT turns it into actual science. We're finally building a tool that can go look for the answer.
Now, you're probably wondering what something like this costs. As you can imagine, a machine this revolutionary doesn't come cheap. The price tag is estimated at a cool $1.6 billion.
But here's a fantastic way to think about that number. That's about the same price as the world's tallest building, the Burj Khalifa. So for the cost of one skyscraper, we're building a machine that could fundamentally change our understanding of our place in the entire universe. It really puts things in perspective, doesn't it?
So, after all that engineering, all the money, all the innovation, it all boils down to this: the single biggest question that this giant eye on time is being built to answer.
And with first light on the horizon, the answer is coming. For the first time in history, that age-old question feels like it's finally within our reach.